This clip covers setting up a hydraulics calculation within Innova engineering. So, much like for the torque and drag example, I'm starting here with our BHA created in the BHA example. If you haven't watched the Creating a BHA video yet, go ahead and watch that first, and that will get you to this stage. So in order to run and set up a hydraulics calculation, you need to input a drill string with detailed component details. Next, we have to input the weld geometry. The weld geometry is a representation of the inner diameter of the weld bore from surface to your TD of this section. So in this case, we'll have 9 5/8 casing at 5,000 feet. And then open hole to TD at 15,000 feet. Okay, in this case we don't have a TVD calculated because we haven't input our surveys yet. Save that. Next we input the fluid properties. So in this case we're doing a 12 ppg oil-based mud, so 2225 for PVYP. If you want to run Bingham fluid model for the calculation, then this is sufficient data. Okay, so we've input our fluid details. Surveys are the next thing that we need to input. So in this case, I'm going to input well plan, but you can input actual surveys as well. So in this case, we tie on its surface. We are vertical to 5,100 feet. Then we kick off and at 6,000 feet, land off. And TD at 15,000 feet. Okay, so I've input a well plan to run our calculation with. Next, we go back to the weld geometry and just cycle through this MD and it automatically calculates our TBD. Next, we go to the engineering parameters tab. So we're not interested in the torque and drag details here, exclusively the hydraulics, flow rates and tripping speeds section. So in this case, as I mentioned, because I've only got a mud weight PVYP, I'll be running the Bingham model, but you can select Power Law, Herschel, Bulkley or Robertson Stiff if you've got the viscometer readings in as well. Surgeon swab reference, so when it's running the surgeon swab calculation, whether you have open-ended BHA or close-ended. If you're running a non-ported float, then close-ended would be what you'd select. Surgeon swab reference, in this case I'll have it a bit, but you can make it whatever depth that you would like, whether it be bit, shoe, bottom hole, or user-defined depth. ROP, I'm going to say is 110 feet an hour, RPM 120. ECD adjustments for correlating with real-time data, so I'm going to leave that at 0. Saltwater density is for when you're doing riserless hydraulic calculations, so that doesn't get used. Surface pressure loss I'll put in as 50, and I will put the calculation depth as the TD of the section because that's what I'm interested in. Flow rate 450 GPM. If you input it as normal, the software will calculate an increment automatically, or you can put it as a manual flow increment and denote as many different flow rates as you require. Same for the tripping speed. If you put in 100 feet an hour, the software will deduct a percentage and create automatic tripping speeds. Again, you can put in manual increments if you so wish. So it will calculate hydraulics for these different flow rates and the surgeon swab for these different tripping speeds. Last thing I have to do on this page is the survey selection. So I input my survey's well plan level, so I need to select well plan. Save. The last thing I do before calculating my hydraulics, I go to the options and hydraulics model options. So in here you can adjust mainly for the surgeon swab these settings used in that calculation. Okay, so I'm going to go calculate hydraulics, and you'll see now the software has calculated the hydraulics for the setup that we put in with this drill string, in this wellbore geometry, with this fluid, in this wellbore deviation, and with these parameters. Within the hydraulics results, this is just a very quick view window, and you can select the different flow rates depicting the bit hydraulics, the overall summary of the hydraulics, and then a breakdown of the drill string components and what intervals and pressure losses there are and velocities over those intervals. To view the results proper for the hydraulics, go to Hydraulics Results, Hydraulics Charts, Hole Cleaning Charts, and then the actual data tables that the charts are created from, as well as the hydraulic summary. If I click Hydraulic Summary, it will create a summary report for us with the input parameters that the calculation was run with, and then a brief summary of the bit hydraulics, overall hydraulics, and then a breakdown of the drill string, as well as some of the results that we had in our quick look view. It also inputs some of the charts that we've got. For the charts themselves, we go to the ECD chart. All these charts are fully editable, and each line depicts various different flow rates or parameters. So in this case, we've got clean, dirty ECDs at different flow rates, and also the ECD snapshot at different flow rates. And then within the hydraulics results, you've also got the data that that chart is created from. Again, exportable. That completes the brief introduction to hydraulic setup within Innova Engineering.